Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face Trending List, published on July 30th, 2025. So, just yesterday. This paper introduces a new model that achieves some major gains on tough multimodal reasoning tasks, including a 7.6% boost on the geometry at 3K benchmark. The paper is titled VL-Cogito, Progressive Curriculum Reinforcement Learning for Advanced Multimodal Reasoning. And the training strategy behind these results is really quite clever. The authors use a novel framework that systematically teaches the model with progressively harder problems, while also rewarding it for adjusting its reasoning length based on the task's complexity. Alright, so this figure gives a great overview of their framework, called Progressive Curriculum Reinforcement Learning. You can see it takes a base model and trains it through 3 stages, easy, medium, and hard, to create the final VL-Cogito model. A key part of this is called online difficulty soft weighting. This system dynamically focuses the training on problems of increasing difficulty. And in that final hard stage, they add a dynamic length reward. This reward encourages the model to use longer reasoning for complex tasks, while keeping answers concise for simpler ones. Building on that online difficulty soft weighting system, these 3 graphs show exactly how it works across the different training stages. On the bottom axis, you have accuracy, essentially how often the model gets a question right. On the side, you have weight, which determines how much focus the training process puts on that question. You can see that for the easy stage, the system prioritizes questions the model already answers correctly. The medium stage targets that sweet spot, around 50% accuracy, which is ideal for learning. Finally, the hard stage really pushes the model on problems it struggles with. So, how does this progressive training actually translate into performance? Well, this table lays out the results comparing VL-Cogito against other multimodal models, which are models that can reason about both images and text together. The benchmarks are split into tough categories like mathematics, science, and general understanding. And as you can see, VL-Cogito consistently comes out on top. It achieves the highest score on 6 of these 10 benchmarks, showing major gains over its base model. For instance, a 7.6% jump on geometry at 3K. Okay, so to really dig into why their method works so well, the authors did what's called an ablation study. This is where they break down their training framework piece by piece to see what each part contributes. This table shows that process. It starts with a baseline training method called Group Relative Policy Optimization. Then, it adds the progressive curriculum, and finally, the dynamic length reward. And you can see that just adding the curriculum provides a consistent boost. But the full VL-Cogito model, with all components combined, gets the best average score, especially on the harder math and logic tasks. So to bring it all together, the VL-Cogito model really highlights the power of a structured progressive training curriculum. By guiding the model through tasks of increasing difficulty and rewarding adaptive reasoning, this approach delivers some impressive, state-of-the-art results. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.